Something is happening to one of the brightest, most familiar stars in our night sky, and scientists now believe they've finally uncovered the truth behind its bizarre and unpredictable behavior. Betelgeuse, our closest red supergiant and a ticking cosmic time bomb, has been dimming, swelling, twisting, and defying every model we've built to understand it. But the real reason behind its strange behavior is far more shocking than anyone expected. To understand why Betelgeuse behaves so strangely, we first have to confront a brutal cosmic truth. This star is living on borrowed time. Sitting roughly 650 light-years away, Betelgeuse is a red supergiant so massive, so unstable, and so close to the end of its life that astronomers describe it as a stellar time bomb, counting down to a titanic explosion that will reshape everything we thought we knew about dying stars. Betelgeuse isn't just big, it's colossal. If you placed it in the center of our solar system, its surface would extend beyond the orbit of Mars, swallowing Mercury, Venus, Earth, and probably leaving the outer planets bathed in a dim blood-red glow. It's around 900 times the radius of the Sun, but only about 10 times more massive. That mismatch makes it extraordinarily fragile. Its outer layers are so thin and swollen that gravity struggles to hold them together, allowing enormous convection cells, each bigger than our entire solar system, to churn, collapse, and burst across its turbulent surface. And that turbulence is the first clue to Betelgeuse's strange behavior. Stars this massive don't just live, they fight. Deep in their cores, nuclear fusion races through hydrogen and helium, then carbon, oxygen, neon, sulfur, all the way to iron. But iron is the end of the line. It cannot produce energy through fusion, so once a red supergiant's core fills with iron, the entire star begins its irreversible collapse. Pressure drops, the core contracts, energy production falters, and the outer layers, already unstable, begin to pulse, dim, brighten, and twist in unpredictable rhythms. This is exactly what we've seen from Betelgeuse. Over the past few decades, astronomers have documented wild fluctuations, rapid contractions, mysterious brightening events, and, of course, the infamous Great Dimming of 2019, when Betelgeuse suddenly lost 2/3 of its brightness, sending the world into a frenzy. Many believed it was the final warning, the moment before the star detonated in a supernova, visible even in the daytime sky. But the truth turned out to be more complicated. Space telescopes revealed that Betelgeuse hadn't dimmed because it was collapsing, but because it had ejected a massive cloud of dust and gas that cooled, expanded, and briefly obscured the star from our view. A cosmic burp, not a death rattle. And yet, this event told astronomers something critical. Betelgeuse is shedding material at an alarming rate, suggesting its internal structure is shifting faster than expected. This leaves us with the question that haunts every astronomer studying this star. How much time does Betelgeuse really have left before it explodes? Some models suggest tens of thousands of years. Others propose centuries. But a small group of scientists analyzing Betelgeuse's unexpected expansion and chaotic convection patterns argue that the end could be much closer, possibly even within our lifetime. And yet, there is one more twist, a hidden process, a missing piece of the puzzle, one that could completely rewrite our understanding of why Betelgeuse behaves so strangely. To uncover the truth behind Betelgeuse's bizarre behavior, scientists needed to look beyond simple dimming events and brightness cycles. They had to peer into the very heart of the star itself, a place so violent, so chaotic, and so alien that even our most advanced models struggled to capture its complexity. And what they found revealed a story far stranger than anyone expected. The key lies in Betelgeuse's rhythms, a series of overlapping pulses, swells, contractions, and temperature shifts that play out over months, years, and even decades. Most red supergiants have fairly predictable cycles, but Betelgeuse, it moves to a rhythm that borders on the impossible. Its fluctuations are irregular, overlapping, and often contradictory. One cycle suggests expansion, another suggests contraction, a third implies cooling, a fourth points to heating. Sometimes they sync, sometimes they collide, and sometimes, for reasons no one understood, they completely vanish. That mystery deepened in 2019. During the Great Dimming, not only did Betelgeuse lose brightness, it shifted shape. Interferometry images showed the star temporarily collapsing on one side, as if some unseen force were tugging at it from within. This asymmetry was unheard of. A normal pulsation couldn't explain it. A simple dust cloud couldn't cause it. Something inside Betelgeuse was stirring, something powerful enough to warp an entire hemisphere. So scientists turned to new tools: supercomputers, deep spectrum imaging, and infrared measurements capable of piercing Betelgeuse's turbulent outer layers. What they discovered was astonishing. Beneath the glowing surface, Betelgeuse isn't smooth at all. It's boiling. Huge convection cells, bubbles of plasma the size of Earth's orbit, rise and fall in great waves. Some collapse violently, creating shock fronts that ripple across the star. Others expand until they burst, flinging material into space like solar flares on a monstrous scale. These eruptions help explain why Betelgeuse flickers and surges, but even they couldn't fully account for the sheer magnitude of its strange behavior. Then came the breakthrough, a discovery so unexpected that it forced astronomers to rethink everything they thought they knew about Betelgeuse. Hidden deep within the data, buried in subtle inconsistencies in brightness, temperature curves, and radial motion, scientists detected a faint, periodic wobble. Something was subtly pushing and pulling the star in a consistent rhythm. Something massive, something orbiting, a companion. For over a century, it had been suspected that Betelgeuse might be part of a binary system, but finding such a partner was nearly impossible. Betelgeuse's surface was too unstable, too bright, too chaotic. That changed when the Great Dimming allowed telescopes to see slightly more contrast in its surrounding space. Two independent teams traced the star's shifting motion across the sky and found a repeating pattern that could only be explained by an orbiting body. That companion, now nicknamed Beetle Buddy, may be no larger than the Sun, but its gravitational pull is enough to subtly distort Betelgeuse's shape, cycles, and internal processes. Each orbit stretches the star, compresses it, or shifts its convection patterns. And when those distortions align with Betelgeuse's pulsing internal cycles, the entire star behaves unpredictably. Suddenly, the last decade of strange behavior made sense. The rapid contractions, the unexpected brightening events, the asymmetric dimming, even the apparent panic signals astronomers thought could precede a supernova. It wasn't just internal instability, it was a two-body dance, a gravitational duet between a dying giant and its faint companion. But here's the twist. This discovery wasn't the final answer, only the beginning, because hidden behind Betelgeuse's rhythms, beyond the dust clouds and convection storms, lies another anomaly, one that challenges the very physics of massive stars. Betelgeuse appears to be rotating far faster than it should, and that mystery is far more alarming. For decades, astronomers believed they had a solid understanding of how massive stars rotate. The bigger and older the star, the slower it should spin. That rule has held true across thousands of observations until Betelgeuse shattered it. When data from the ALMA telescope revealed that Betelgeuse appeared to be rotating at nearly 5 kilometers per second, the scientific community was stunned. A red supergiant of Betelgeuse's size simply shouldn't be capable of rotating that fast without tearing itself apart. To put this into perspective, imagine our Sun, which rotates at about 2 kilometers per second. If it suddenly expanded to Betelgeuse's radius, its rotational speed would slow to just a few meters per second. That's basic angular momentum, the same reason a figure skater slows down when she extends her arms. But Betelgeuse, far larger and more massive than the Sun, seems to be doing the opposite. Instead of slowing, it's spinning with a velocity that defies fundamental physics. So what's really going on? The ALMA data showed a clear Doppler shift across the star. One side slightly bluer, the other slightly redder. Under normal circumstances, this gradient would be a textbook indicator of rotation. One hemisphere moves toward us, the other away. Case closed. But Betelgeuse is anything but normal. As simulations of the star became more advanced, scientists uncovered a startling possibility. The supposed rotation might be an illusion. Betelgeuse's surface is a boiling, turbulent ocean of plasma. Enormous convection bubbles rise and collapse at speeds reaching 30 kilometers per second, far faster than any true rotational motion. When these massive bubbles surge upward or fall back into the star, they can mimic the Doppler pattern of rotation, creating the appearance of a smooth gradient where none exists. In other words, Betelgeuse might not be spinning fast at all. The star's rotation could simply be the chaotic motion of its own surface. But this explanation only raised more questions. If Betelgeuse isn't rotating rapidly, why are its convection patterns so extreme? If it is rotating rapidly, what event gave it such impossible momentum? One hypothesis suggests a dramatic past. Betelgeuse may have devoured a companion star, absorbing its mass and angular momentum. Another proposes that its interior structure, the layers where fusion occurs, may be rotating separately from the outer shell, producing misleading signals. No matter the explanation, one thing is clear: Betelgeuse is hiding something deep within its core, and the secrets behind its strange behavior are about to get even stranger. For more than a century, astronomers had suspected that Betelgeuse might not be alone. Its strange pulsations, irregular brightness cycles, asymmetrical dimming, and unexpected surface distortions hinted at forces acting on the star from the outside. Subtle gravitational nudges that couldn't be explained by convection cells or internal instability alone. But the evidence was always too faint, too inconsistent, and too easily obscured by Betelgeuse's own violent nature. Everything changed after the Great Dimming of 2019. With renewed global attention and more telescopes focused on Betelgeuse than ever before, scientists began analyzing high-precision positional data spanning decades. What they noticed was extraordinary: a repeating wobble in the star's motion across the sky. A tiny shift, subtle but consistent, that recurred in a cycle of several years. It was the signature of gravitational influence, something pulling on Betelgeuse, then releasing it, then pulling again. Two independent teams, one from the Harvard-Smithsonian Center for Astrophysics and another from the Flatiron Institute in New York, reached the same conclusion. The only explanation was a hidden companion star. A smaller star, likely no larger than our Sun, was orbiting Betelgeuse at a distance comparable to the gap between the Sun and Saturn. A star so faint, so overshadowed by Betelgeuse's massive luminous body that it would remain invisible to most telescopes. But its gravitational fingerprints, those were unmistakable. In early 2023, astronomers using the Gemini North Telescope in Hawaii finally captured a blurry but compelling image, a tiny point of light, 6 magnitudes fainter than Betelgeuse, located exactly where models predicted the companion should be. It wasn't definitive proof, but it was the strongest evidence ever obtained. The companion was real, a star now informally nicknamed Beetle Buddy, and this revelation changed everything about how scientists understood Betelgeuse's strange behavior. For one, Beetle Buddy's gravitational pull likely explains the star's longest brightness cycle, the mysterious 2,170-day pattern that had confused astronomers for decades. Instead of being an internal oscillation, it was the orbital period of the companion, subtly but continuously stretching and compressing Betelgeuse's outer layers as it moved. Every close pass disturbed the red supergiant's convection patterns. Every distant pass allowed the star to relax. And when these periodic disturbances aligned with Betelgeuse's internal pulses, chaos erupted. Suddenly, the rapid contractions made sense. The asymmetrical dimming made sense. Even the bizarre shape changes photographed during the Great Dimming now fit into a coherent model. Betelgeuse wasn't merely unstable, it was being influenced. And Beetle Buddy wasn't the only surprise. Once scientists incorporated the companion into their models, another anomaly stood out. Whenever the companion reached certain orbital positions, Betelgeuse's rotation measurements became even more distorted. The same Doppler signatures that had confused researchers at ALMA occurred more strongly during these periods. This suggested that Beetle Buddy might not just be orbiting, its presence might be affecting Betelgeuse's convection and surface velocities in ways never before documented. All of this brought scientists to one startling realization: Betelgeuse's behavior cannot be understood unless you consider it as a two-star system. But discoveries rarely solve everything. They usually lead to deeper questions. If Beetle Buddy exists, is it the star's original companion? Or is it what remains of a star Betelgeuse already consumed? Some astronomers believe Betelgeuse once had a more massive partner that spiraled inward millions of years ago, its outer layers stripped away and absorbed by Betelgeuse. The core of that star could now be what we call Beetle Buddy, a surviving remnant of a stellar cannibalism event. This would explain Betelgeuse's rotational anomalies, its wild convection, and its strangely high momentum. Others propose a different scenario. Betelgeuse and Beetle Buddy formed together, as binary stars often do, and Betelgeuse's expansion into a red supergiant created a violent gravitational relationship that destabilized both stars. But regardless of which origin story is true, the implications are staggering. Betelgeuse's strange behavior, its dimming, swelling, twisting, brightening, cooling, wobbling, and chaotic surface storms, isn't random. It's the result of a complex gravitational dance with a hidden partner, a dance that may influence when and how Betelgeuse finally explodes. And that brings us to the final and most haunting question of all. What will Betelgeuse's supernova mean for us? And could it happen sooner than anyone expected? The answer lies in the final session. Now that we understand the forces twisting Betelgeuse into something unpredictable, its unstable convection, its turbulent interior, its mysterious rotation, and its hidden stellar companion, there's one question left. When will this enormous star finally reach its breaking point? And what will the moment of its death look like for us? To answer that, we need to revisit what a star like Betelgeuse truly is. A massive nuclear engine running out of fuel. Deep in its core, fusion has already forged the heaviest element it can: iron. Once enough iron accumulates, the engine stalls, gravity wins. The core collapses in a fraction of a second, triggering a shockwave so powerful it rips the entire star apart. That moment is inevitable, but predicting when it will happen is one of the hardest challenges in modern astrophysics. Some models suggest Betelgeuse could have less than 10,000 years left. Others place the estimate closer to 100,000 years. But a small group of researchers has proposed a more dramatic possibility, that Betelgeuse may be far closer to detonation than we think, possibly within the next few centuries, or even the next few decades. This controversial idea began when scientists recalculated Betelgeuse's radius. If the star is larger than previously believed, it may already be in a far more advanced stage of fusion than current models predict. In this scenario, the Great Dimming could have been a symptom of core instability rather than just a superficial dust cloud. And the long-term patterns in Betelgeuse's brightness, once attributed to internal cycles, may instead be signs of deep structural shifts. But what about Betelbuddy? Its discovery complicates things even further. The companion's gravitational tug may be subtly accelerating Betelgeuse's instability. If Betelbuddy's orbit aligns with certain internal oscillations, it could push the red supergiant closer to collapse faster than standard models anticipate. This doesn't guarantee an imminent explosion, but it changes the timeline in ways scientists are only now beginning to understand. So, what happens when Betelgeuse finally goes supernova? First, the explosion would light up our sky like a second sun, bright as a full moon, and visible even during the day. For weeks, the night sky would be dominated by a glowing beacon unlike anything seen in recorded human history. It would be breathtaking, beautiful, and scientifically priceless. But dangerous? Surprisingly, no. At 650 light-years away, Betelgeuse is too distant to threaten Earth. The shockwave will weaken to nothing long before it reaches our solar system. The radiation will be diluted by distance and shielded by the heliosphere. Humanity will be perfectly safe. What we will gain, however, is something extraordinary: a front-row seat to one of the most spectacular events in the universe. A live demonstration of the death of a massive star. A once-in-a-lifetime cosmic spectacle. When Betelgeuse explodes, it will not be the end. It will be a beginning, an opportunity to rewrite everything we know about stellar evolution. And when it happens, the entire world will look up. If this journey through Betelgeuse's mysteries fascinated you, imagine what we'll uncover in our next episode. The universe is full of secrets, and we're just getting started. Subscribe so you don't miss the next breakthrough. Like this video if Betelgeuse's story blew your mind. And tell me in the comments, do you think it will explode in our lifetime?